Hello, today we're carrying on looking at coordinate geometry and we're going to have a look at finding the midpoint of a line. Here we have a nice picture so we can clearly see that the midpoint of the line is going to be here, but in an exam it will be a wordy question and you'll have to extract the information. So the first thing to do is have a look at what I'm doing in my x and my y to go from the coordinate I'm given to the second coordinate I'm given. Well, here I'm going across and I'm going across 6. And then I'm going up 4. Well, to get to the midpoint, I want to do half of that. So rather than go across 6, I want to go across 3. And rather than go up 4, I want to go up 2. So if I start at 1, 2, and I go across 3, and I go up 2, then 1 plus 3 is 4, and 2 plus 2 is 4. So you can see that I'm getting to the coordinate 4, 4. That's fine if I have a nice picture where I can see all of that from, but as I say, in an exam question you're not very likely to have that. So we need to find a method which will work just from the coordinates. So what we're going to do is we're going to find the average. We want the x coordinate in the middle of the two coordinates I'm given, and the y coordinate in the middle of the two coordinates I'm given. My midpoint, I'm going to abbreviate midpoint to MP, is equal to, well, my x coordinate is my first x coordinate plus my second x coordinate divided by 2. Just like we were finding the mean, add up all the numbers, divide by how many numbers there are. And the same with my y coordinate, so I'm going to do y1 plus y2 divided by 2. So in this case, I would be doing, my midpoint would be equal to my first x number, well that's 1, plus my second x coordinate, well that's 7, divided by 2. And for my y's, I'd have my first y coordinate as 2, plus my second y coordinate, which is 6 over 2. And then you can quite quickly see 1 plus 7 is 8 divided by 2, so that's 4. And 2 plus 6 is 8 divided by 2, and that's 4. Now let's have a look at a slightly different question. And this question is if I'm given the midpoint. So here I've got the coordinate 2, 1, and I know that 3, 4 is in the middle of my line segment. The question is, what's the end point? Now I could use the formula for this, but that's making it harder than it needs to be. So what I'm going to do instead is I'm just going to say, what do I have to do to go from here to here? Well, I'm going across 1 and I'm going up 3. So I'm just going to do the same thing again. I'm going to go across 1, I'm going up 3. So 3 across 1 takes me to 4, and 4 up 3 takes me to 7. So I can see that 4, 7 is my final coordinate. Let's have a look at a couple of exam questions involving the midpoint. So the first one is taken from an OCR paper. It says the line joining the points A at 4, 5 and B at PQ has a midpoint M at -1, 3. Find P and Q. Well, just like I've been recommending before, if we're not sure what's going on, let's draw a picture. Well, we've got points A and we've got a point B and we've got a line joining them. A is at 4, 5, B is at PQ, and then the second bit of information tells me that the midpoint, so the midpoint of my line M, is at -1, 3. Again, just like all my other videos, I know this isn't accurate. I know that -1 is not to the right of 4. That doesn't matter, it's just trying to get an understanding of what's going on. Now I've got my picture, I can very quickly see I've got the midpoint in the middle of my line section, so I can just think, what do I need to do to go from A to M? Well, to go from 4 to -1, well, I've got to take away 5. And to go from 5 to 3, I'm taking away 2. And then I'm just going to do the same again. So I'm going to do -1. Before I had to take away 5, I'm going to take away 5 again, which is going to get me to -6. And for my Q, I had to take away 2 before, so I'm going to take away 2 again. So that ends up being at 1. So the question asks us to find P and Q. Let's make it very explicit to the examiner, but P is at -6 and Q is 1. So just a quick recap on that. I'm starting at 4, 5. I know that I'm going to -1, 3. and I'm finishing it at PQ. So we said, what do I have to do to go from here to here? I take away 5, so I'm going to take away 5 again. That takes me to -6. What do I have to do to go from here to here? I'm taking away 2, so I'm going to take away 2 again, and that leaves me at 1. So P is -6, Q is 1. That's as simple as an exam question will be. Let's have a look at a slightly more involved one. So this is an exam question from Edexcel. It says the points P and Q have coordinates -1, 6 and 9, 0 respectively. The line L is perpendicular to PQ and passes through the midpoint of PQ. So we've got to get used to this notation. PQ means the line connecting the points P and Q. So let's draw a quick picture. Here I've got P, here I've got Q. Again, I'm not looking for accuracy here. It's just to get a general idea of what's going on. -1, 6 and 9, 0. So these are my 2 points. Then we know that we've got a perpendicular line to PQ. So here I'm going to draw in the line PQ. So this line here is PQ. We're looking for a perpendicular line which passes through the midpoint. So let's put in the midpoint. And perpendicular lines, remember, are at right angles. And we know from the video on perpendicular lines that the gradients multiply together to give me -1. So we're asked for the equation of this line. Now it's really important we practice finding perpendicular bisectors. And then for some reason, whenever you get asked for a line through a midpoint, everybody then finds the perpendicular bisector. Really read the question carefully. Does it say perpendicular to the line PQ, or does it say parallel to a different line? Does it give you a gradient? You've got to read the question really carefully to get the information out. So, as usual, we're looking for the equation of a line. I need 2 bits of information. We know that I need to find a coordinate on the line, and we need to find the gradient of the line. So let's start with finding the coordinate on the line. Well, there's one coordinate which I know about on the line. That's the coordinate which is the midpoint of PQ. So let's see if we can find the midpoint of PQ. Well, we know that M, the midpoint, is going to be at, well, it's the midpoint of my x coordinates. So I'm going to add my 1 and my 9 together, get 8 divided by 2, and that's 4. And then I'm going to do the same for my y coordinates. So 6 add 0 is 6, divided by 2 is 3. So I know that the midpoint of my line is at 4, 3. The next bit of information I need is the gradient. Well, what I do know about the line is it's perpendicular to PQ. So if I can find the gradient of PQ, then I can find the gradient of my line. So, as I've said before, there are 3 ways in Core 1 of finding a gradient. I could rearrange the equation of a line into form y equals mx plus c. Well, I don't have any equations of lines, so I can't rearrange an equation into form y equals mx plus c. I could use 2 coordinates. I have 2 coordinates. And then the third way was differentiation, which we're going to use if we've got a curvy line. It's not a curvy line, they're straight lines, so I can't use that method. So it must be the 2 coordinates method. Well, if you remember, we said that to find the gradient, we were going to do the change in y over the change in x. Well, here I'm starting at 6, that's my first y number. I'm going to 0, so I'm going down 6. So I'm going to put -6 in my change in y. And then my change in x, well, I'm starting at -1. I'm going up to 9, so I'm going up 10. So I get the gradient -3/5. Now that's the gradient of the line PQ, not the gradient of the line I want to find. The gradient of the line we want to find is perpendicular. So hopefully we remember that to find the perpendicular gradient, I'm looking for a number which when I times -3/5 by, I'll get -1. And we know that that's a negative reciprocal. So in this case, that's going to be 5, 3. Again, in layman's terms, flip it and change the sign. So now we've got a coordinate on the line. We've got the gradient of my line. So I'm all good to go with finding the equation of my line. We need to remember that when we're finding the equation of a line using a coordinate and a gradient, we're going to use the form of the line y minus y1 equals mx minus x1. So in this case, I'm going to do y minus my y coordinate, well my y coordinate's 3, equals m, which is my gradient, so that's going to be 5/3, x minus my x coordinate, so I'm going to get x minus 4. Now, we've got the equation of a line, but we don't have it in the form ax plus by plus c equals 0, and we need a, b, and c to all be integers. So because we need them all to be integers, I'm going to get rid of my fraction first, and I'm going to do that by multiplying everything by 3. So I'm going to get 3 times y is 3y, 3 times minus 3 is minus 9, 3 times 5/3 is 5, and then the brackets is multiplied by 3 because we've times the bit at the front by 3. Now I'm just going to expand my brackets, so I get 3y minus 9 equals 5x minus 20. And then rearrange. It doesn't matter which side I take everything to, because I like having a nice positive x, I'm going to take it all to the right hand side. So I get 5x minus 3y, and now I get minus 20 plus 9, which is going to give me minus 11. And now I've got it in the form ax plus by plus c equals 0. Don't panic if you have negatives, they're still integers. Minus 3 is a whole number, it's an integer. So that's okay. So you can see now just how long and involved these questions can become. You've really got to keep your wits about you as you're going through this, remembering the key points which we've talked about. So to find the equation of a line, you need a coordinate and you need a gradient. You then need to work out how you're going to get those key bits of information, and remember to finish it off at the end and don't just go, here I've got the equation of a line, I've finished. Actually make sure you get it into the right form, the form that they've asked for, in this case 5x minus 3y minus 11 equals 0. And that's it. So I hope that's helped you with your coordinate geometry, and you're now ready for when it comes up in the Core 1 exam.